सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Novel therapeutic formulation developed for improved treatment of Indian red scorpion sting. A new therapeutic drug formulation, TDF, comprising of low doses of commercial equine anti-scorpion anti-venom ASA, adrenoreceptor agonist, and vitamin C for inhibiting the Indian red scorpion venom. Inducted toxicity and associated symptoms can help improve clinical management of scorpion sting patients. Scorpion envenomation is a severe problem in many countries of the world. The Indian red scorpion, with its life-threatening sting, is one of the world's most dangerous scorpions. Intravenous administration of equine anti-scorpion anti-venom raised against M. terminus venom (MTV) is the only available treatment for scorpion stings. However, the low proportion of venom specific antibodies against the most abundant low molecular mass channel toxin is a barrier to efficient clinical management of scorpion sting patients. Therefore, the high anti-venom requirement may lead to adverse serum reactions in treated patients. Scorpion envenomation and its treatment needs extensively research and alternative therapies. Conventionally, alpha 1 adrenoreceptor agonist such as prazosin is also used alone in combination with commercial ASA for the treatment of stung patients. However, this therapy is less effective and associated with certain limitations. To solve this critical issue, a team of scientists from Institute of Advanced Study in Science and Technology, IASST, an autonomous institute of Department of Science and Technology, as well as researchers from the scholars from Tezpur University, NIELIT Guwahati, have invented novel therapeutic drug formulation comprised of low doses of commercial ASA, AAA, and vitamin C for inhibiting the Indian red scorpion venom, inducted toxicity, and associated symptoms. The drug's efficacy was first tested as Canorhaptus elegans, a free-living nematode model, as an alternative to an vivo animal model. The research was recently published in the journal Toxins. An Indian patent has also been filed on this novel drug formulation. The study by the team comprising Professor Ashish Mukherjee, Director Dr. M.R. Khan, Associate Professor, and Dr. Aparoop Patra, IPTF. From IASST, Dr. Bhabana Das and Upasana Pujari from Tezpur University and Dr. S. Mahanta from NIE-LIT Guwahati demonstrated for the first time that C. elegans can be a good model organism for screening the neutralization potency of the drug molecules against a neurotoxic scorpion venom. And the novel TDF efficiently neutralized the Indian red scorpion venom, induced increase in.
Now, our next segment is Analyst in STEM.
Today we are with Dr. Balasubramanian Sundaram, Professor, Chemistry and Physics of Materials Unit, Jawaharlal Nehru Center for Advanced Scientific Research.
Computers, such as some of you may have heard of something called supercomputers. We use supercomputers in our group to study problems in chemistry and material science. When I use the word chemistry, I include certain aspects of biology and also physics into it. So we use these terms somewhat loosely, somewhat more liberally, but my area of expertise is in what is called computational chemistry. And specifically, we've been looking at solutions, solvents which are environmentally benign, environmentally good. There are many reactions are required in industry, for instance, which for industrial processes, and these have to happen in a solution. And these solvents used in those reactions, they could be environmentally not benign. Okay, they could evaporate and cause pollution in the air and so on. So, can you have recyclable solvents, which are not as volatile as the current day solvents? That's number one. Another area of research is the common public would have heard of something called carbon dioxide emissions are increasing due to human activities and so on. That's what is called anthropological matters. And so can we sequester carbon dioxide? Okay. Sequester means can you separate carbon dioxide? 30% of global carbon dioxide emission comes from what is called a flue gas. But when you burn coal, you have largely carbon dioxide and along with sulfur dioxide and water vapor and so on. Okay. So can we, in the flue stack, you have a pipe or something like that. In the stack, can we separate the carbon dioxide and store it into a compound, into a solid compound? Then it's not getting into the atmosphere. Okay. These technologies exist, but current day technologies use a lot of energy. They use using a process called chemisorption. That is, they form a chemical bond. The compounds that are used to sequester carbon dioxide, they form a chemical bond with the carbon dioxide. So if you want to release carbon dioxide back, then you need to break that chemical bond, for which you need to supply heat. So that's, once again, heat is energy. So where do you produce that energy from? Okay. So are there ways to capture carbon dioxide in a physisorption manner? I'm using these technical terms, chemisorption and physisorption. These are not known to the common public, but I'm guessing that students of science must be listening to your radio podcast, and that's why I'm liberally using these terms as well. And common public, there's nothing wrong, harmful for them to learn some science. The other thing that we have been also looking at is doing, all these are in computational chemistry. I do not have an experimental laboratory. So people may have, when they think of the word chemistry, they may think of colorful solutions, your high school practicals, labs and so on. I do not have any of that. I recreate all of that within computers. Okay. So another thing that some of my students are working on now is something called direct air capture of water vapor. So it's a humid day, but let us say it's not raining, or let's say Bangalore is quite dry all through the year largely, right? Unlike, let's say, Chennai or Mangaluru, for instance. Or think of Ladakh, very dry, very rarely does it rain. How do people there meet their needs for water? Right? Okay. So of course they need to depend on glacial melts and so on and so forth. But is there a way to? But there is water vapor in the atmosphere, in the air. Okay. In the air there is water. Water molecules are there, but they are just few and far in between. That they start condensing to form a liquid. Can we have a compound? Okay. If I show that compound to air, it will invite all the water molecules to come inside it and it will form a liquid inside that. Okay? Yeah. These compounds exist. These compounds have been synthesized in the world. Not one or two, but several. Okay. So we are studying how such compounds operate from through computers, what is called computer simulations. And within these methodologies, there's wonderful fundamental physics inbuilt into it. You cannot forget that. I may have told this in a layman language, but you need to know a lot of mathematics, you need to know a lot of physics, you need to know a lot of chemistry to do this sort of thing. So that's in and a lot of computer programming as well. Very important. Computer programming. So that's in a nutshell what we do.
Thank you, sir. So my next question is, how is your research beneficial to a common man or India as a whole, and what kind of contribution is it making to the field of science in India?
Okay. You may have already guessed the examples I chose. There are other drier, less human impactful research that we spend time on, but I told you the examples that getting water in Ladakh from air, or in Rajasthan from air it is impactful for man, for human beings, right? But however, as I told you, the water that I collect is inside a computer. Right? But I look at the fundamental processes that are involved in getting the water inside. How is that useful? Because whatever insights I provide from my computer simulation are going to spur experimentalists who synthesize new compounds which may be more efficient than the compounds that they. So for that they require the fundamental understanding. So that's the aspect. In Indian science as well, we work a lot with other experimental groups in India. Okay. We collaborate a lot. We have joint publications, joint research, original research publications. So that way, and we are involved in a lot of activities of teaching the way how we work, the techniques we employ to other scientists and other students in all across India. So that way, it helps other people.
Yes. Could you brief about your past, present, and future area of research?
My past research, probably about a decade or so, was on this environmentally benign solvents, industrial solvents that I told you. Okay. I've kind of stopped doing that kind of work now. So currently we've been working on a lot on battery electrolytes. Okay. As all of you know, you use solid state batteries in your mobile phones, but we primarily in my lab we look at liquid state electrolytes. Okay. What you have in your car or your two-wheeler, they are largely liquid state, lead acid batteries and so on. So we study those sort of, and how to improve their performance, how to improve their life and recyclability, these sort of things. Okay. So that's the current thing. We also use a lot of machine learning, something called a machine learning. I'm guessing, since Bangalore is the IT capital of almost the world, I'm guessing there are surely lots of people who are doing machine learning in Bangalore outside of science. Okay. And we do use machine learning tools to advance these computational methods.
Okay. Do you have any idea about where is India right now ranked at in your field of research?
In my field of research, I would say probably because we are large in number, not because we are doing cutting edge per se. There are several small European countries which are doing more cutting edge research than than India. But however, since we are many in number, so I would say in my area of research it will be the same rank as Indian science in general. I'm guessing Indian science may be 4th or 5th. I do not know where it is placed.
It would be more helpful if you could give some information about your contemporaries.
In
your field of research.
In my field of research, you mean names?
Names.
Names. Oh, that's a very, very good question. And I'm going to bat for many young people. I'm 57 years old, and long past my youth. Okay, so there are many young people who are doing excellent work. For instance, I would like to mention Jagannath Mondal from TFR Hyderabad, Nishant Nair from IIT Kanpur, Tarak Karmakar, who was my own student from right now in IIT Delhi, and Deva Priya Kumar from IIIT Hyderabad. These are some of the names, and in IIT Madras, Rohit Batra, Tarak Patra, and so on. There are many names.
Okay, so thank you. How are Indian industries associating with your research project?
I was trying hard to answer this question because we were prepped that these were the questions. Answer is unfortunately none. There is none, and I do not. With the current trajectories that Indian science, Indian industry, and Indian society is taking, Indian society, not just government, I do not envisage any greater participation from Indian industry, into fundamentals. At all, unless there's a huge course correction and they got to mend their ways, and I don't think they will mend their ways because money isn't there.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts.